Hi, good afternoon. Thank you for joining the LINKPlanner webinar. It's 1:01 Central Daylight Time right now, and it looks like we've got about 51 attendees, so I think we can go ahead and get started. So my name is Brian Chan. I'm the Regional Technical Manager for the South Central United States, and I'll be your host for today's webinar. So today we'll be talking about LINKPlanner and the capabilities and functionalities of this planning tool that is offered free of charge from Cambium. So we'll also be talking about how to use this tool, how to import some sites, how to plan licensed as well as unlicensed point-to-point links, point-to-multipoint links, how to read the performance predictions, how to generate bills of materials and reports. And we'll also talk about the ins and outs of the software and how to become a little more efficient when you're using LINKPlanner. So for those of you who have not used LINKPlanner before, you can download this from our website. So you can just go to cambiumnetworks.com. You can navigate over to products, click on LINKPlanner, and this will take you to the site where you can actually download the firmware. Again, there is no cost to this, so as long as you have an account with Cambium Networks, you can log into the support center and then download the appropriate installer. So there are two. There is an installer for Windows as well as another one for Mac. So depending on which one you're using, just download the appropriate one. There are some differences between the two. I think Mac does not support Google Maps functionality, if I'm not mistaken, but otherwise the two are fairly similar. So once you have that downloaded, this is what LINKPlanner looks like. So when you first open up the software, this is what the homepage looks like for the user interface. So there are certain links up at the very top where you can ask questions to the LINKPlanner team, or where you can navigate to the Cambium community forum to ask questions or post some of your experiences and your stories. So before I continue, can you guys see my screen and hear me okay? There's actually no moderator for today's webinar, so I just want to make sure that everything is smooth. Can you guys hear me? I just want to make sure I'm not talking to myself. Can anyone just type something into the chat box to say, yes, this works, or no, you can't hear me? Loud and clear. Okay, perfect. I will continue once I figure out how to move this off screen. Okay, so again, this is what the user interface looks like. So to get started, if you have any questions, especially if you are new to LINKPlanner, you can click on this quick tutorial, or you can navigate to the user guide. The user guide is actually a very useful resource. So anytime you have questions, you can just open up this PDF, type in your questions, and chances are the answers exist in this PDF document. As far as contact details go, depending on where you are planning your links, this will have information on your respective regional sales manager, or if it's a more generic question, or if you have problems with your Cambium equipment, you can also reach out to tech support. And then at the very bottom, there's just a list of recent projects. Okay, so let's go ahead and create a new project and start planning some links. So to do that, you can just go to File and then go to New Project. And once you create a new project, this is what it looks like. So there's fields at the very top of this project where you can enter in information about your customer, the company name, contact information. So it's more for your own administrative purposes and accounting. This information does get published within the PDF report that you can create for projects. So it's also pretty useful for that regard. As far as project properties go, the prediction model has two options. One is the Gantt-Barnett, the other one is ITU-R. So ITU-R is the default setting. So for most of you who are new to LINKPlanner, the default setting that your LINKPlanner will show is ITU-R. So you can definitely change that to the Gantt-Barnett. We do recommend changing this for North America because the way that this prediction model works for modeling rain rates as well as worse earth curvature and ducting scenarios is a lot more accurate for North America. So you don't want to use I2-R for North America because this will actually plan links in an overly optimistic manner, and chances are you will see performance predictions that are exceeding what you will actually see in the field. So you definitely don't want to do that. For SM antenna height, this is not too relevant if you're planning only point-to-point links. This is basically a universal setting for setting all of the subscriber module heights. So if you want it to default to maybe 12 feet, for example, because you're planning point-to-multipoint links for a wireless ISP and they have a bunch of SMs and you don't want to have to change each one individually, you can plan all of the links and then change it after the fact, or you can just set this before you start planning those PMP links, and all of those subscriber modules will adopt this global setting. And at the very bottom, there is the maps area, which shows where the locations are over Google Maps, or if you want just white space just to see the coordinates and where they are relative to each other, you can click on the offline map. Of course, Google Maps does require internet connectivity, and if you want to have your sites overlaid over Google Earth or a satellite view, all you have to do is click on the satellite button, and that will show you basically a Google Earth overlay. So it's definitely a very useful tool for planning links and taking a look at the viability of individual links. But before I actually jump into the planning, let's take a look at how to customize LINKPlanner to where you have settings that are set up the way you want it. So if you go to Tools and then Options, there's a field for personal information. So you do have to set this up if you are using this for the first time, because this will actually give you access to our 2D terrain profile data. So once you're set up, every time you create point-to-point or point-to-multipoint links, they will automatically generate 2D terrain profiles. So if you're not set up with our path planning service, you will not get any of that data, and this tool will not be very useful. So be sure to enter in all of the information here that it requires from you, especially your email address. For templates, so if you're using this for the first time, you should not have any templates preloaded. So I've got a few in here because I've actually created these templates. So what happens is anytime you make a change and save it as a template file, not as a project file, but as a template file, you can then open up this template file and set that as the default to where every subsequent project adopts those settings. So the biggest one that we talked about was the prediction model, right? So if you wanted to have every project open up with a Vigandt-Sparnet prediction model, you could actually make that change. So let's go ahead and do that right now. So let's say that you're new to LINKPlanner, you've made a change to where you've selected Vigandt-Sparnet, and you don't want to have to change it from I2-R every time you create a new project. Then after making this change to Vigandt-Sparnet, you can go to File, Save As, and then save it to wherever you want your templates to be located. Maybe that could be the desktop or a folder within your documents, it doesn't matter. So instead of saving the file as a default of LINKPlanner project, you can save it as a template. So you can save that as a PTP template, hit save. I've already got templates set up, so I don't have to do this. And then go back to Tools and Options. And when you navigate to templates, you should then be able to navigate to wherever you save that file within your template directory, point to where that is, and then this should now populate with that template that you've just saved. So that saves a lot of time because whenever you create new projects, each new project that you create that uses this template will save you from having to make all of those changes every single time you open a new project. So continuing on, units are also another option that you can customize. So height, I believe, defaults to SI, which would be meters, which is great for the rest of the world, but here in the United States, at least, we want to use feet. Length can also be changed from kilometers to miles. Latitude and longitude just depends on what your preference is for viewing your lat longs. So that can either just be degrees in decimal format, or degrees in minutes, or degrees, minutes, and seconds. The MAC address, if you want to enter in your MAC address into these point-to-point links, you can certainly do that. And these are the different formats that are accepted for the MAC address. For default PTP regions, so this is typically organized alphabetically. So like 5.1, for example, starts off with Algeria and then Argentina, so on and so forth. So if you plan a point-to-point link or a multi-point link, that region code is automatically going to show Algeria. So for 5.1, for example, I have not changed this. I am surprised. So since we are planning most of our links in the United States, if I want that to be the default region, all I have to do is select the United States and then click on the up button until it's at the very top. Click on OK. So now every time I plan a 5.1 link, the region code will automatically be on the United States. So depending on what frequency ranges you're typically selling equipment for, you're going to want to go to those bands and select the appropriate region codes and set those up to the top. So if you do a lot of licensed microwave, for example, in 11 gigahertz, and you're in the United States, you want to set the FCC to the very top. If you're doing a lot of unlicensed 5.8 links, you want to go over to 5.8 and make sure that the United States is at the top. So this is going to save you a lot of time. And the same goes for PMP regions. So it's the exact same thing there. Network settings, I have not had to change. Path profile, so this is where you have to register for the path profile planning service to where it'll automatically generate 2D terrain profiles for you. So I've already registered, so my screen might look a little bit different from yours. If you're using LINKPlanner for the first time, there might be a big button on getting registered and set up. So just be sure to go through that process. And as long as you have a Cambium Networks account, that is easy enough to do. Reports. So LINKPlanner can generate proposal as well as installation reports. And installation reports are very useful because it'll have all of the information that an installer would need for installing a point-to-point link or multi-point links. So that'll have azimuths, antenna heights, frequencies, channel sizes, etc. All of that good stuff in a report. So to customize that report, you can change the font, you can change the page size. So this is where you make those changes. For graphics, once we start plotting sites and links, you'll notice that there are standard colors that are used. So if you wanted to change those colors, you could also do that here. The bill of materials is also another very useful function of LINKPlanner. You can create a full BOM for point-to-point and multi-point. So here in this option for bill of materials, you can select where the mains leads should be for. So that can be the United States here, which is also the same in Canada for the North America. So as long as this is checked, the BOM will automatically populate with the appropriate mains lead to where it can plug into the correct wall outlet. So if you leave any of this unchecked, it's basically not going to populate with the mains lead. So your bill of materials may actually be missing certain components. Okay, so now that we've gone through the customization of LINKPlanner, we can start planning some links. I live in the city of Austin, so I have already kind of set my LINKPlanner to Austin, and I've also created a few sites into a CSV file just to show you guys how to import coordinates for planning purposes. But if you don't have a CSV file with coordinates, or a Google Earth KML, KMZ file that you can import, you can definitely enter in the coordinates individually. So that certainly takes a little more time, but it is something that we do support. So this can be done by using the shortcuts in the menu bar. So this icon that appears to be like a tower with a lightning bolt represents a new network site. So every time you want to create a new point-to-point link or an access point, this is the icon that you would use. So you can click on that icon to give your site a name, to designate the maximum height or the tower height or structure height, as well as entering in latitudes and longitudes. So one thing to note about latitude and longitude input is that you can either do that by decimal or degrees, minutes, seconds. So for example, if I wanted to enter in 36.5 as a latitude, that is that can work. If I wanted to enter in degrees, minutes, seconds, I would separate them using a colon. So maybe 36 colon 30 colon 0 to represent 36 degrees, 30 minutes, 0 seconds. So those are the formats that are accepted. So that's what the shortcut in the menu bar is looking for. It is looking for a specific coordinate. If you don't have the coordinates, but you do know where it exists in Google Maps, you can enter in that location by clicking on where that location exists. So it doesn't take in addresses. However, you can basically just point and click on a map. So for example, if there is a location in campus, for example, I can turn on satellite view, zoom in on campus. Maybe I want to do some Wi-Fi to the stadium, and I want it to drop a point-to-point link. I would then click on the new network site, and then basically click on that point to create that location. So you'll notice that the latitude and longitude has already been populated based on where I clicked. So now all I have to do is give it a name and a height. Other shortcuts that you may use include new subscriber sites. So this is the icon that shows just 3 dots. This represents a subscriber site. So if you are planning point-to-multipoint links, then you'll need one network site for your access point location, and then you can plot multiple subscriber sites for your PMP links. The icon that shows a green line between 2 dots is the shortcut for a new PTP link. If you click on this button in the menu bar, it's looking for locations for a from and a to. So if I have multiple coordinates entered in, I can click on those separate coordinates to create point-to-point links. Otherwise, if I wanted to basically click between 2 points on a map, I could use this shortcut within Google Maps. This icon is for creating a multi-point hub. So as long as I have several network sites, I can click on this button to designate certain towers as hubs that can have one or more access points. And this icon over here is also commonly used. This is for integration into Google Earth. So any coordinates, links, whether they're point-to-point or point-to-multipoint, will be generated within Google Earth, and they will be generated in 3D, which is very useful for determining whether any obstructions are infringing upon for null zones, or if you have line of sight, near line of sight, or non-line of sight conditions. And these 2 buttons are for reports. So the proposal report PDF is this icon. The one just to the right is for an installation report. Basically, a proposal report could be for like an RFP or RFQ, where you don't want to provide too much information. And an installation report will have greater minutiae with regards to installation instructions and azimuths and bearings and antenna heights, so on and so forth. So I already have some coordinates in a CSV file. So just to show you guys what that process of importing coordinates looks like, you can go to File, Import. So here is how you can import network sites or subscriber sites. So I don't have them saved in a KML or KMZ. However, if you do have pins saved in Google Earth, you could use that. I have saved them to a CSV file. So I'm going to go ahead and import my network sites. I'm going to hit open, and I'm going to hit next. So once I hit next, this is asking me which columns should be imported. So these columns represent names, latitudes, and longitudes, or heights. So you just want to make sure that all of these columns correspond to the correct information. So if my latitude and longitude was reversed, for example, I could designate this one as latitude and this one as longitude, if that were the case. So there's a lot of flexibility here. The max height, for some reason, defaults to meters or SI. Since we are in North America, we want to use imperial, so we're going to select feet and hit next. So this will show where those coordinates exist relative to each other in the offline map, and I can hit finish. So once I hit finish, those coordinates will be entered into LINKPlanner. So now I can click on the home button to basically zoom to fit. If Google Earth or the satellite display has too much information and it's too busy, you can definitely click on the Maps tab just so that you don't get overloaded with information. So from here, we can plan some point-to-point links. I also have some subscriber sites that I would like to import to show you guys how to create some point-to-multipoint links. So the process is the same. Instead of importing network sites, I'm importing subscriber sites. So I can click next, verify that all of the information is correct, change max height from meters to feet, and then hit next. Again, it shows me where these locations are relative to each other in an offline map, and then I can hit finish. I can zoom to fit again by hitting the home button. So now we've got all of my coordinates from network sites to subscriber locations that allows me to plan point-to-point and point-to-multipoint links. So let's go ahead and create a link. So I'm going to go ahead and connect the state capitol to the Frank Erwin Center, which is just an arena. So once I create that link, LINKPlanner will automatically create it for me. So you'll notice that now I can expand on PTP links. It's no longer blank like PNP links. So I can click on this individual link to make changes. So one thing that I want to touch on before we go into the link planning is that this has adopted parameters from an equipment template that I created. So if you're following along on LINKPlanner and you're using LINKPlanner for the first time, chances are it may have selected a different product. It should be showing United States as long as you followed along and set the region code to United States for 5.8. I think LINKPlanner does default to 5.8 being the default band when you're first creating a point-to-point link. However, it may not default to 30 megahertz, and it definitely does not account for interference by default. So this is an equipment template that I created. So if there are certain links that are more commonly planned by yourself that you would like to create a template for, you can do that by going to Project Configuration and then PTP Equipment Templates. So you'll notice that I've got 3 equipment templates here. The first one is the default, which means that every time you create a new link, it will adopt these parameters. So once I double click on that or click on Edit Template, it will bring up a pop-up with the template to allow me to make changes to that template. So this is my default template. So I've set it for 5.8 gigahertz, which is the unlicensed band. I've selected PTP 670, which is our unlicensed sub 6 gigahertz wideband radio that goes from 4.9 up to 5.8. I've set it for the regulation code of the United States. Precise network timing is basically for support of precision timing protocols like IEEE 1588, V2, or SYNC-E, which is more for carriers. I don't really deal with that too much, so I'm leaving that disabled. I can also select the default bandwidth that it uses every time it creates a link. I think 30 megahertz is generally a pretty good channel size, but depending on where you are, if you're in a noisier area where you're always planning links that have to be in smaller channel sizes, you can select something like maybe 20 or 15 or 10 megahertz that's smaller. As far as E1s, T1s go, the 670 does support that, but I don't generally deal with that very often anymore, so I've left that on none. I've set my optimization to IP. Sync, if you are doing a lot of PTP links, perhaps you may want to enable sync and select a specific sync source like PTP sync or CMF5. You can set your symmetry. So these are TDD links, so they take turns transmitting and receiving, so the symmetry can be set. Dual payload should be enabled to basically double the capacity, since these are OFDM MIMO radios. They are capable of transmitting 2 separate streams of information across the V and H polarizations. You can cap your highest modulation mode. I generally like leaving it at the highest possible modulation mode so that adaptive modulation can vary down to the lowest Ethernet mode and up to the highest mode. You can also set your master site. So interference generally is not checked by default. I like checking this so that interference is accounted for. And this is very important for unlicensed links, because typically when you are deploying unlicensed links, no matter where you are, there's almost always going to be noise, unless you're in the middle of the ocean or out in the Arctic Circle. But for most locations, you do have to contend with interference. And this is a field that you can adjust as well. So minus 75 dBm in a 30 megahertz channel is fairly conservative. If you are traditionally planning links in areas that have much lower interference, you can certainly set this lower. Maybe if noise in a 30 megahertz channel is generally minus 85 dBm for you, you can change this to minus 85 on both locations. So that is my template for 5.8. So you'll notice that when I created that link, it adopted all of those parameters, which saves a lot of time, because without this template, every time I plan an unlicensed link, I do have to make the appropriate setting changes, and I do have to click on interference every single time without this template. I've also created additional templates for licensed microwave. You'll notice that these are not bold, which means that these are not the default templates. If I were to be creating a project file for licensed microwave, I could select the appropriate template, set it as a default, and then from there, every time I click between two coordinates to create new links, they will then adopt the parameters in these templates. So this is a huge time saver. So going back to this link, we've already covered most of these equipment options, so there's no reason to go through that again. So below that is the path profile. So this is the path profile, the 2D terrain profile that has been imported from our database. So this is SRTM data. If I wanted to take a look at what this link looks like in Google Earth, all I have to do is click on the Google Earth icon or shortcut, and this will then zoom in on Google Earth with that link overlaid over Google Earth. So this is really useful because if you are planning links in areas where Google Earth has 3D terrain data, whether that's buildings or trees, then the modeled Fresnel zone can be investigated more thoroughly to determine whether this is line of sight, near line of sight, or non-line of sight. So it looks like, at least on the capital end, I may have overestimated its height. It's depicting the Fresnel zone a little higher than where it should be. But I do see that at 0.1 mile, or at this mile marker, there is a building that's about 10 stories high. So from here, I can actually assess the path and do a virtual site survey to determine whether or not this link is line of sight. So if I go back to LINKPlanner, at 0.1 mile, we had a 10-story building with some pretty tall AC units at the very top. So assuming 12 feet per story, that's 120 feet plus the AC units. So let's call this maybe a 140-foot obstruction. So by hitting enter, this allows me to update the terrain profile to determine whether or not that obstruction is infringing upon my Fresnel zone. So this is what allows me to do a virtual site survey to determine the viability of the link, even before doing a physical site survey, which can save a lot of time, manpower, and money. So it looks like this is fine, but also the capital may not be 300 feet. If I go with 200 feet and then update that, looks like it's still line of sight. There's a parking garage at 0.2 miles, but that's pretty low, so I'm not going to worry about that. At 0.4 miles, I think this is a hospital. This is about 4 stories, maybe 8 stories tall. So let's call this, and this is at 0.3 to 0.4 miles. So I'm going to drag and select 0.3 to 0.4, and I'm going to call it about 100 feet. Hit enter. And since that is on a low point, that is not infringing upon my Fresnel zone, so this link is line of sight. So since it's only half a mile, going with the default antenna size of the high gain integrated antennas is definitely sufficient. If this were a longer link, I could also change that antenna selection. So with high gain integrated antennas, they're 23 dBi in gain, but they also have a relatively wide radiation pattern when compared to dishes. So if you are a little concerned about noise, especially in this example here being downtown, there might be a lot of noise from several sources. You definitely want to narrow your radiation pattern. So you could do that by going with a connectorized 670 and using an external parabolic dish, like maybe a two foot high performance parabolic. Since this is such a short link, by selecting a larger dish size, you won't see any sort of performance improvement. However, in the real world, you could see that your noise actually decreases because of the use of a parabolic dish or a high performance parabolic dish. And of course, interference is checked because of the template that we were using earlier. So depending on what the noise actually is like in this link, that could also have an impact on performance. So once the link is installed, you could actually come back and update this information to see if there are any changes in the predicted performance based on different levels of interference, etc. So now that we've finished that design, there are different fields that we can look at to determine the performance of this link. So there's a performance summary, which shows the predicted receive level based on all of the setting changes that we've made based on the product type, dish size, interference levels, etc. And you can also set a mean required IP throughput, as well as a minimum required IP throughput and a minimum required IP availability. So if this is being designed for a customer that requires maybe 200 megabit circuit, you would put in 200 as their target. And if they want to have at least 5 megabits per second at 5 nines, you would then make those changes to the minimum IP required and minimum reliability. So let's change that. So I'm going to set this to 200 as well. I'll set the minimum requirement to 5 as well as 5 nines. So if any of the requirements are not met, you'll see that that field will turn red, which means that it's failing. So this link is designed in a 30 megahertz channel size. It can only achieve 300 megs, which does not meet the required 200 megs in each direction, which means that we have to use a larger channel size. So if I change this bandwidth to 45 megahertz, we are now achieving 452 megabits per second aggregate, which is delivering 226 megabits in each direction. So now this passes. So those are pretty useful fields for determining the viability of the link and whether that meets the customer's design criteria. So here under performance details, there are two tabs. One is for charts, which show availability as a function of capacity. So this will show you what the link availability is like for the different modulation modes that are delivering different levels of capacity. I generally like to use the details tab more than the charts tab because it gives me more information. So under the details tab, this is actually showing all of the different possible modulation modes that this radio can operate in and what the associated fade margin is, as well as throughput, and how much time the radio will actually spend in each of these modulation modes. So the 670 can modulate up to 256 QAM, and it can modulate down to BPSK. So in 256 QAM, we will deliver 452 megs of aggregate throughput. This has a fade margin of 5.25 dB, and LINKPlanner is predicting that this link will spend 99.9807% of its time in 256 QAM and a fraction of its time in the lower modulation modes. Most notably is 64 QAM being the lowest modulation mode that this link should ever be in, because it's such a short link with such a high receive level. So it should never really drop down into the lower modulation modes. And then at the very bottom, there's a bill of materials. So this bill of materials gives a full list of part numbers as well as descriptions for equipment that would be required for the implementation of this link. So it includes everything from the actual radio to warranties, Cat5 cables, lightning protection units, grounding kits, etc. So any questions so far before we continue? There's usually a moderator. This is my first time using GoToWebinar, so bear with me. Okay, so we do have a question here that says, in a link profile, how to set an obstruction type and attenuation of that obstruction. Okay, that's a good question. So I've shown you how to set obstructions, but as far as setting the attenuation, that is not possible. So the way LINKPlanner models these obstructions is it models it as a dense object, as a solid object. So even though the 670 is capable of non-line of sight operation, if you put in an obstruction in LINKPlanner with, I guess, severe enough height, you'll actually see that that link probably does not work. So if I put in a 200-foot obstruction here, for example, especially being in an urban environment, especially if you use integrated antennas, there's a chance that those reflected signals off of that urban corridor can be reconstructed at the receiver to maintain that link, which we have done in several areas, including New York. We do have a few case studies there. So even though it could work, LINKPlanner is pretty conservative in the way it models these non-line of sight conditions. And so it models it as a solid object, and chances are LINKPlanner will then show you that it does not work. So you cannot adjust the attenuation. You can't say that the obstruction that you've entered in is a tree with certain absorption and reflection properties. LINKPlanner is just going to make an assumption and basically assume that it is a solid object. So let's see if there are any other questions. We do. Can an AP work with different bandwidth towards different SMs? Let's see. Not quite understanding this question, I guess. If you set an AP for a certain channel size, you just have to make sure that the subscriber that you want to connect to that AP has the appropriate channel size set in its scan list. So if you have an access point set on 20 megahertz and you have connected 20 megahertz SMs to it, and you have one that's set to scan 10 megahertz only, it will not connect. You do have to set that for 20 on the scan list. Where to get terrain data for countries on South and Central America. Okay, so as long as you register for our path profile service, you will have this information. So it'll automatically populate your 2D terrain profile data as long as you're registered with the service and you're creating point-to-point links or even point-to-multipoint links. Doug asked, isn't minus 37 RSL too hot and a risk to burn out the front end of the radio? Yeah, so good question. We do have different thresholds for different radios. For the 670, that threshold is generally minus 35. If you wanted to set an ATPC target of maybe minus 40, you can definitely do that. But as far as LINKPlanner is concerned, it just make sure that you do not exceed minus 35 for PTP 670. Channel size shall be the same for all SM referring to an AP. Okay, so this is probably back to the same question as earlier. Yeah, that will be no problem then. Are you going to perform PMP? Yes, so let's go ahead. We've gotten a few PMP questions and a request for PMP, so I'm going to go ahead and plan some point-to-multipoint links. But before we do that, let's go ahead and zero out this obstruction so this link is no longer failing. Okay, so going back to our map, I have planned an unlicensed link. If we have time, it's already 1:39, I've got about 20 minutes. If we have time, I'll show you guys how to plan a licensed link as well. But I think PMP is going to take precedence since we haven't shown that yet. So to plan a point-to-multipoint link, you can click on the icon that shows a tower with some access points on it. And if you hover over it, it says New Hub. So I've got a few subscriber modules that are located just to the north of the Westland Tower. So let's go ahead and designate the Westland Tower as a hub site. So once you do that, you can designate the number of APs at that location and the starting azimuth. So even though you can set maybe 4 APs for 360-degree coverage, I like always starting it with 1, because once you make changes to that access point, you can then add additional access points that then adopt the parameters of that first AP. So that saves a lot of time because you don't have to create 4 APs within the hub and then change every single one to the appropriate band and product type. So here we've got SMs that are just to the north. So I'm just gonna create one axis point facing the north, being 0 degrees, and I will set my max range to 1 mile, since these are generally pretty close to the tower site. I'll hit OK. And so now you'll notice that there is a sector coverage pattern. So one caveat is that this is not a heat map or a coverage map. This is just showing the modeled beam width of the sector antenna. So now under PMP links, I can expand this. I can expand my hub site, and I can make changes to the axis point that has just been created. So again, you'll notice that this may be different from your link planner if you are following along. And the reason for this is because I did create an equipment template for point-to-multipoint. So I set a default template for 450M in 5.8. So let's go ahead and plan for a 450M, and at the same time, I can also showcase the massive multi-user MIMO capability of a 450M. So we can just set this to 5.8. We can select a 450M. These are, of course, the other options available that are band specific. So if I had selected a different band like 2.4, for example, you would most likely see a much smaller list of only related products to 2.4. So I also want to set my country code to United States if that hasn't already been done. Again, this is based on a template, so this has already been set for me. Sync input. Auto sync is for synchronization. If this is the only AP in your network that is not being synchronized, you could set this to generate sync, but generally this does not really have much of an impact, if at all, on the predicted performance. Encryption variant, we do support AES or none. Operating mode, for now, let's go ahead and set this to sector mode so that we can see what the single user MIMO performance is like, and then we can do a deeper dive into multi-user MIMO. 20 megahertz channels are probably the most common channel sizes that are selected, which gives you the ability to have several different frequencies and do frequency reuse and not occupy too much spectrum to where you may be dealing with a lot of noise. Color code, this is how SMs register to an access point, but this does not have any impact on performance, so it doesn't really matter what you select. Although if you do select the appropriate color code, that will show up on the installation report that you give to your installers. So there is a benefit here to selecting the correct color code. Adjacent channel support is if you're doing adjacent channels in 450Bs. Range units, we want miles. I think if you're using this for the first time, chances are it's going to show up in kilometers. So we're going to set this to 1 mile. Frame period, so you can select either 2.5 milliseconds or 5 milliseconds. We can just leave this on the default for now. You can also cap the number of registrations allowed. So the 450 allows up to 238. If you wanted to ensure that you don't exceed maybe 40, just so that you don't have too many SMs on an access point, you can also set this to a lower limit. Downlink data, if this is for a wireless ISP, generally they want 75 to 85. So we'll leave this on 75. Contention slots, we will support auto contention slots here in an upcoming release, but for now this does have to be set. I think I've only got 20 or so SMs connected. So the recommendation is 3 slots for 1 to 10, 4 for 11 to 50, and 6 for 51 to 150. So let's change that to 4 so that this is more accurate for an actual real world deployment. Broadcast repeat count can be set between 0 to 2. So yeah, it looks like we're good to go. So this tower is 300 feet, but generally you don't have to set your APs that high, just as long as they have a good height to establish line of sight connections. For this location, let's go ahead and select 100 feet. And we can also set a channel plan. So this is one thing that I created in my overall link planner template. I did create a channel plan, so chances are you're not going to see this unless you also created a channel plan. But with this channel plan, you can also assign specific access points, specific frequencies. So I've got 6 different channels within 5.8. So I can select any one of these since there's only one of them. But this does color code your access point. So if you have a huge network of several access points, If you want it to color code your channel plan, especially if you're doing frequency reuse, this could be very beneficial. So I'll take a look at this after planning our links. So based on the settings of azimuth and model beam width and where these SMs are relative to this AP, I can connect all 23 subscriber modules. So I'll click on OK to get them added up. So while that is running the calculation, I just want to talk quickly about the two buttons up here. So the two to the left of the search bar is for automatic calculation. So that gives you the ability to make changes without having to manually calculate every time a change is made. So this is nice for smaller projects. If you have a larger project with hundreds of subscriber module sites, instead of having LINKPlanner run through the iterations every time you make a change, you might want to turn this off to only do the changes once you're ready to run an updated analysis. Okay, so this is predicting 129.4 megabits per second for 23 connected subscriber modules based on sector mode. So that's with single user MIMO. So for this 450M, if we wanted to see how much more throughput we would achieve by enabling multi-user MIMO, you can change that operating mode to MU MIMO, and we'll see that this should improve the overall throughput from 129 megs to 515 megs. So this is a testament to the capacity of the 450M and its ability to group multiple subscriber modules simultaneously. So this is 515 megabits per second in a 20 megahertz channel. Okay, so I think that covers most of that. So one other thing is tilt. So there's a really cool button that will actually determine for you what the optimum up tilt or down tilt is for your axis point. So you can set a range that you want it to assess and an interval. So once I perform this tilt calculation, it will run through several iterations to determine what the throughput would be anywhere from -5 degrees down tilt to +5 degrees up tilt in 1 degree intervals. So based on 100-foot antenna height for the axis point and 33-foot heights for the SMs, yeah, I think those are still on default. This will then run that iterative analysis to determine the optimum tilt so that we can generate the highest throughput. So while that's running, let's see if we have any questions. What to do to evaluate the interferences in case the maps are not available in 3D. So I'm assuming you mean physical interference and obstructions. So for that case, if Google Earth has Street View, I do use that a lot. So a lot of areas do not have 3D objects, you are correct. But I do like using Street View and just doing an estimate of obstruction heights, whether they're houses or trees or downtown buildings. Any plans ever to support a heat map? Interesting question. We do have plans. We're working on something right now, but that is a secret, so I probably should not have said that. Okay, so the tilt calculation is done. So you'll see that based on different tilts, there are different predicted throughputs. So we definitely don't want to do up tilt because that gives us the lowest amount of throughput. And if we do 2 degrees of down tilt, that gives us the same performance as what we have right now. And there also is 2 degrees of electrical down tilt in the 450M, and LINKPlanner does account for that. So this tilt is the actual physical tilt to implement. Since 0 degrees gives us the same performance as 2 degrees of down tilt, it might be easier for installers to just install it flush. So I will set it to 0. It's already on 0, so I can basically just close this out. One other thing to show you guys is making a mask change. So my equipment template for point-to-multipoint had 450B high gain SM selected. I think those are probably the most common SMs that will be used for the 450 platform. However, if you have close SMs that are within maybe half a mile that you want to use the 450 mid gain, then you can select those SMs. And then instead of changing them one by one, you can actually make a mass selection, right click on the product, click on edit product, and then you can change that product. So this is a huge time saver. This is something I learned recently from Dave Hensley, who's on the LINKPlanner team. He's one of our RF planning engineers. So before I knew about this, I had to manually change dozens and dozens of subscribers. So this saves a lot of time. So if I wanted to change this to 450B mid gain, I can make that selection, and this should then automatically update the table with that info once it's done. Okay, while that's still working, okay, no questions. Okay, so I've made that change. You'll notice that since this is sorted by product, those have all gone to the bottom. So like SM1, for example, if I clicked on that, if I clicked on that link to assess that individually, you'll notice that that now has the 450 mid gain antenna selected. Okay, so I think that covers all of the planning. We've talked about customizing options, planning licensed and unlicensed links, the tilt calculator, bill of materials. Also, so at the very bottom of this, instead of generating bills of materials per platform, you can generate an overall bill of materials for the entire project. So if I click on any one of these buttons for exporting the project to a workbook, that will then create an Excel workbook with all of the project's equipment. So that has point-to-point in a separate tab, multi-point, access points in a separate tab, subscribers in a separate tab, or all of it lumped together in a full bill of materials. So from here, you can put this into your pricer to get pricing for your projects. Okay, so let's talk about all of the options within project configuration. So we still have 7 minutes, so we've got time to go through this. So PTP antennas is a list of all of the point-to-point antennas. So if you wanted to enter in your own, you could click on New Antenna, put in information about the manufacturer, the dish size, description, and then you could also enter in the appropriate gain in the different bands that you're creating this antenna for. Same goes for subscriber module antennas. AP antennas does not allow for you to add antennas, but this does give you a full list of all of the PMP infrastructure antennas for access points. TDD sync is for synchronization of unlicensed sub 6 gigahertz links. So for creating the parameters for max burst duration, frame offset, etc., this is where you would go to designate those parameters. Custom fields. So if there are not enough fields for you in LINKPlanner, you can also add fields. So for example, maybe your network sites, maybe you want FCC registration numbers in there. You could put in FCC registration, default value, you can just leave that blank. So now, whenever I go to my network sites, I can actually put in FCC registration information for each of those locations, which you could also enter into description, so it's not a big deal, but just wanted to show you guys how to create custom fields. PTP link formatting, so I got this from Dave Hensley as well. Basically what this does is anytime a link matches a certain rule, it will then format that link with a different pattern or color so that you can easily differentiate what you're looking at within LINKPlanner. So instead of seeing a bunch of green links, you can see different colors that represent different frequencies and whether or not they're meeting your requirements. And you can do the same thing for PMP formatting. As far as templates go, we did talk about that already. So one thing that I wanted to show you guys is that since lower 6 gigahertz 820S and 11 gigahertz 820S are not default templates, they're basically dormant. However, you can actually apply a template. So if you have a customer who plans something in unlicensed and then wanted to see what that performance would be like in license, you can go to your table of links, right click anywhere, and then navigate down to apply equipment template, and then select the appropriate template. So if I applied my 11 gigahertz 820S, sorry, 820C, I misnamed it, 820C equipment template, you'll see that that is no longer a PTP 670 in 5.8. It's now an 11 gigahertz licensed 820C link. Continuing on, channel plans. Yeah, so I didn't show you guys how to create a channel plan, but you'll notice that for the 450M, there was a channel plan dropdown. And the reason for that is because I created a channel plan for the 5.8 gigahertz band, specifically for 450M in 20 megahertz channel sizes. So as long as you have a channel plan that matches an AP's settings as far as product, country code, and bandwidth go, you will then see that drop down to where you can select that channel plan and you can select the appropriate channel. So really, this is more useful for larger networks with many access points so that you can have a color-coded channel plan. And you can see where you might want to change your channels to avoid secondary self-interference. So this is really good for that. If you only have one or two APs, it may not be as beneficial. BOM estimator. So I've got 3 minutes. So the BOM estimator is a really useful sales tool. So if you don't want to do a full path analysis and you just wanted to generate a quick BOM for a customer, you could basically click on BOM estimator, come into either the PTP or PMP tab or even Wi-Fi, click on new configuration, and then you can basically select a band, a product type, close out that pop-up, and it'll create a full bill of materials for you. So if you're doing a licensed 11 gigahertz 820C link, for example, let's do 820C FCC. Let's go with 2+0 XPIC, multiple Ethernet without lag, 80 megahertz channel sizes, 2-foot dishes. Okay, so once I close that out, I've got a full BOM, which I can then export to a workbook or view in Excel as a spreadsheet. So this has the radios, accessories, lightning protection units, all of the necessary activation keys, like your second core activation key, XPIC, your second gigabit Ethernet port, etc., etc. So all of that information is here for a full bill of materials. Okay, so I think that covers everything that I wanted to cover. We've got about 2 minutes left, so let's go ahead and address any unanswered questions. Can you change the bill of materials based on if you are using a CMM5 or standalone AP? You can, however, it's not really automated, so you can't really tell LINKPlanner that you have a cluster of 4 APs. LINKPlanner, can you please put in CMM5s? But what you can do is you can add in extras. So once I click on that access point and navigate down to the bill of materials, I can click on new extra and I can select the appropriate accessories that are relevant, right? So I could add, so these are extended warranties for CMM5. You can add that if you're adding the CMM5. GPS sync. So here's where you would add a CMM5 controller, a power and sync injector, and also the appropriate power supply. So if it's up to two 450Ms, you can go with the 240 watt power supply. If it's more than two 450Ms, you can go with the 600 watt power supply. And I'm not seeing those here. Well, power supply AC 40. Yeah, so this is the 600 watt power supply. I guess the 240 watt option is not in here. But yeah, so here's your power supply, your CMM5 controller, your sync injector, universal GPS module, as well as the cable that will connect the CMM5 to that UGPS, and warranties if you wanted. Hit OK, and that will then add all of that equipment into your bill of materials. Of course, you would only have to do this for one AP and not for every single AP. Okay, let's see what other questions we have. Is the installation power level during alignment higher than actual operating levels in the PTP line? No, so whatever is shown for a point-to-point link, let's see, so let's go back to unlicensed and let's apply a template back to unlicensed. So whatever you see here for the maximum transmit power takes the antenna gain as well as the free space path loss into account. So if you are on a really short link like this one, it might actually decrease that maximum transmit power. If this is licensed, it'll do the same thing. So for real world operation, you do get to set the maximum TX power, and generally you do want to match your PCNs for licensed links, or you want to match LINKPlanner for more accurate performance, and also to stay within EARP limits, which for 5.8 is pretty high anyway, so it almost does not matter. But certainly for licensed bands or lightly licensed bands, you do not want to exceed EARP limits. Okay, so I think that answers all the questions. Thank you everyone for joining, and we'll talk to you next time.